Hi, my name is Nabil Zaleka, and this presentation is about this feature I'm calling secure mode for cursor. Right now, accidental exposure of API keys and other secrets happens a lot, and it happens in a source file, in a copied snippet, in chats, and even in logs. Often it's something small, like just testing keys that goes pushed or a screenshot that accidentally contains credentials. Even a short exposure can be enough, and bots constantly scan public repos and links. And once a key is pushed up, it can turn into surprise cloud bills, data access that was never intended, and a support ticket that have been handled immediately. So the problem we're trying to solve is how do we reduce these leaks without without slowing people down or making the tool feel heavy? I've broken the root cause into three groups: technical, user, and organizational. On the technical side, my project starts with what I would call a quick and dirty patterns. The developer hard codes a key to get a demo working, then that code gets committed or synced. Starter templates don't always include .env or git ignore, so secret slips into repos or logs. With AI tools in the loop, it's also easy for generated code or examples to embed secrets without the user fully noticing. On the user side, a lot of newer developers rely on copy and paste. They grab something that works, run it, and move on. The security risk is invisible until they get a scary bill or an email about suspicious activity. On the organizational side, teams often don't have a clear guardrails. People feel pressure to move fast, and ownership of a secret management is split between engineering, platform, and security. That means no one fully owns the end-to-end experience of how do we keep keys safe in our daily tools. Here's the, the solution at a high level. First, there is on-device detection. While the developer is typing or pasting, secure modes looks for a pattern that looks like API keys or tokens. This happens locally on the user's machine, so we're not uploading source code to a server. When something looks scary, we show a small, clear prompt rather than a hard block. Second, there is an auto reduction at the moments that matter. When someone shares a code, commits to a repo, or sends a snippet, secure mode automatically hides or masks detected secrets. This cuts off a lot of exposure at the exact point where things usually go public. Third, there's a one key fix. Instead of just saying this is bad, we give a single action like move to env or create a .env file and reference it. On top of that, new projects can start from secure starter that already have .env and git ignore setup. And teams can have an optional org level toggle so that these protections are just the default for everyone. Now let me walk you through what it actually feels like for a developer. Step one is a project creation. The user chooses a secure starter. The starter already includes environment files and ignore rules, so they don't have to think about configuration just to get going. And as they start coding, we move to a key detection. If they paste something that looks like an API key, the secure mode quietly flags it. The prompt is more of a gentle nudge than a loud error. So it offers a one-click fix that moves the secret into .env and replaces it with an environment variable in the code. And when it's time to share or commit, secure mode checks again. If a secret is still present, it will automatically redact it from the snippet, the log, or the sharing link. Depending on the team setting, it can even block the share or commit until the secret is handled. Finally, on the team policy side, these can choose to secure mode for their project. That creates a consistent baseline of protection and helps build a culture where handling secrets properly is just a part of what it means to ship code with Cursor. Any features like this has risks, and I want to call out the main ones and how we handle them. The first risk is false positives. If secure mode flags things that aren't actually secrets too often, people will get annoyed and turn it off. To reduce that, the default behavior is to run rather than block. We start with a soft prompt and one-click fix. During the pilot, we would tune the rules based on real usage so the prompts feel rare and meaningful. The second risk is false negatives. And when a real secrets ship past detection, to address that, we combine patterns matching with interrupt checks and keep an internal test sets for seeded keys. And we can regularly run detection against that set to see where we're missing things and refine the rules. The third risk is privacy. Developers are understandably sensitive about their secure mode, and the secure mode addresses this by doing detection on device. And the code stays on the user machine, so we don't need to upload files to the cloud just to scan the secrets. And there's also a clear explanation so users know what's happening and what's appropriate way to opt out. And looking at this from the developer perspective, there are three big benefits. First, fewer incidents. If secure mode catches potential risks early, developer can simply run into fewer situations where they have to rotate keys or talk to support or worry about what gets exposed. Second, faster recovery. When something does happen, because we provide one-click fixes and tracks where where the secret was detected, the developer can respond quickly. Instead of digging through files or old commits, we're targeting a median time to fix uh, of under 2 minutes during the pilot. And third, a secret mode helps people build secure habits without a lot of overhead. By guiding them in the moment, the tool teaches patterns like using envy bars and keeping secrets out of the logs. And over time, those habits stick even outside of this specific project. And ROI for the business. First, secure mode is expected to reduce security-related support tickets for the tickets. And for the pilot, I'm using a target for about 40% reduction. That frees up support and engineering time that actually goes into incident response and credits. Second, this directly supports brand trust. If Cursor is known as the AI coding tool that takes security seriously and helps users avoid painful mistakes, that builds confidence. And trust is one of the main reasons people stick with the recommended tools. Third one is it improves operational efficiency. Means fewer fire drills means teams can focus on shipping features and improvements rather than reacting to emergencies. And it is also important to think about what happens if we do nothing. If we leave this problem as it is, we can expect ongoing incidents, ongoing repairs or credits to users, and increasing support burdens. And as Cursor user base grows, the absolute number of leaks will grow too, and if the rate stays the same over time, they start to show up as a subtle drag in retention and future deals, and teams that have one or two bad experiences may quietly move away or hesitate to expand usage. Now let's look at the high level of the timeline of the events. Month 1 focuses on the prototype. During this time, we build the basic secure mode experience, secure starters, real-time detection wired into the editor, and the simple reduction at share. We also recruit a small but representative pilot group, ideally a mixture of beginner developers and a small teams. Month 2, we move into internal pilot testing. The goal is to tune accuracy and performance, and we track the false positive rates and aim to bring it under 10% on our sample set. And by month 3, we're ready for a public beta. At this point, Secure Mode has an optimal organizational toggle and a lightweight dashboard so teams can see how it is being used across projects. And this month is about smoothing edges and watching metrics and gathering broader feedbacks. And these are the benchmarks that tell us whether we're on the right track. By the end of month 1, we want the prototype that works fully on a developer machine and a confirmed list of pilot users. And if we don't hit those, it's an early signal that scopes needs adjustments by the end of the month. And by the end of the month too, we want the false positive rate below 10% on our test cases and a median time to fix under 2 minutes. We should also have the top usability issue resolved based on feedback from the pilot. And by the end of month 3, want the public beta live with more than 60% of new projects created during beta using secure mode. And we also aim for a feedback service level with a response time within 48 hours. Okay, and this slide summarizes the budget for the 12-week pilot. First is the personnel at 132,000. This covers backend and security engineering, part-time front-end engineers, product managers, design, and Q&A. These people are responsible for building secure starters, the in-editor warning, the reduction logic, and making sure we're accurate without damaging developer flow. Next is the tools and services. This is 12.5K. This gives us short-term access to secure detection, library, and vendor credits so we can benchmark our local detection at a small value in keys. The third one is infrastructure, which is 3.5K. Because scanning is done on a device, the infra footprint is small. So this line covers the extra compute storage and monitoring for the beta channel and the internal dashboard. And we have $200 for research and accessibility, which is mainly for a quick surveys and a copy review. And we have a contingency of 14.8K. This is a 10% buffer to handle extra fixes, vendor costs, overlays, and a short pilot extensions without blowing the budget. And I want to briefly explain why the budget is shaped this way. Most of the cost is in people, not servers. So this is intentional. The hardest part of this problem is not running regex cover or some code. It's designing prompts and flows that developer will accept and tuning detection so it is helpful rather than nosy. That works if it's in engineering, UX, copy, and Q&A. And on the infrastructure side, costs are low because scanning happens locally on the user machine, and we don't need large service to process code in the cloud. And we mainly need enough capacity to support the telemetry for the beta and dashboard for the team. And the contingency take this because we know from experience that security related work can surface. There will be a surprise cost, and we're trying to avoid that. Okay. When we move to the baby feedback tables, this slide shows how I incorporated the feedback from my peers in the planning of the final proposal. At the time, when I make this slide, only 2 members replied. From Jackie, I got the advice to clearly define the primary user group. In early draft, that was a bit vague, and I took that feedback and now explicitly focus on the beginner developer and small teams, which are new to secure practices and rely heavily on copy and paste. And from Daniel, the key point was about balancing security with usability and keeping cursor lightweight. That's a big reason why I kept detection on device and focusing on warning plus one-click fixes. And instead of aggressive blocking, it's also influenced how I talk about cursor's opportunity to lead in secure AI coding rather than just adding friction. So thank you. I hope you guys learned about my project. And thank you for the time.